Okay, this question here, the cubic equation, this one here, ax cubed plus bx squared plus cx plus d equals 0, has roots alpha, beta and gamma. Write the cubic equation whose roots are m times alpha, m times beta, m times gamma. I'm going to show you the way that the book does it, but we're not going to do it that way again, all right? Because we're then going to do it a second method down here, which is very quick and very easy, and it's the way that Cambridge does it as our second method down the bottom in a sec. All right, so let's start. All right, if that cubic equation has those roots, let's look at sum of roots, product of roots, two at a time. Sum of roots, two at a time, product of roots first. I'm going to use the old method first. So sum of roots is what? Equals alpha plus beta plus gamma, which is minus b on a. Sum of roots two at a time. What did I just write? Sigma alpha beta. Yeah, sum of roots two at a time. So instead of doing this again, two at a time, we're just going to go sigma alpha beta, even though they're not all alpha beta, but that just means the sum of roots two at a time is, isn't it c on a? Actually, look, you know what? No, I won't write it as sigma alpha beta. I know, but I need to write them because we're going to, so it's, sorry, I'll just do them two at a time. Alpha beta plus beta gamma plus alpha gamma is c on a. Product of roots, which is the same as sum of roots three at a time, is minus d on a. That is for the original equation, okay? But for our equation, if the roots are m times alpha, m times beta, and m times gamma, that was for up here, if roots are alpha, beta, gamma, then that's what you've got for sum of roots one at a time, two at a time, three at a time. But if your roots are m times alpha, m times beta, m times gamma, then your sum of roots will be, isn't it, m alpha plus m times beta plus m times gamma, which is m times alpha plus beta plus gamma, which is just m times minus b on a, or minus mb on a. So it's m times negative b on a, which is minus mb on a. Sum of roots two at a time, so I'm just going to go sum of roots two at a time. Isn't it now going to be m times alpha beta? Oh, no, m squared. Won't it be? If these are your roots and you're doing two at a time, it'll be m squared alpha beta plus m squared alpha gamma plus m squared beta gamma, which is m squared times alpha beta plus alpha gamma plus beta gamma, which happens to be m squared, what? Yeah, it's just m squared c on a. I want to try and finish it on that row because I need room. M squared c on a. And the last one, three at a time, have a guess what you'll get. Product of roots, yeah. Products of roots, we're not going to do it like this ever again. It's just going to be m alpha times m beta times m gamma is m cubed alpha beta gamma, which is just m cubed c on a. So therefore your required equation, therefore our required equation, or our required cubic equation is, you know how it's it's going to be x cubed, wait. Oh yeah, it's not c, is it? A, B, C, D minus m cubed, sorry, d on a, thank you. This is the d, minus m cubed d on a. Therefore, your required equation is, isn't it x cubed minus sum of roots x squared plus sum of roots two at a time x minus product of roots? Is it not? Mm-hmm. So it's x cubed minus sum of roots one at a time, which will be minus mb on a, which will be plus mb on a x squared. Then it'll be plus m squared c on a x, because it's sum of roots two at a time times x. Then it'll be minus, but minus m cubed d on a, so it'll be plus m cubed d on a equals 0. That's your new polynomial equation whose roots are m alpha, m beta, m gamma. Now what you can do with that is multiply through everything by a, and you'll get ax cubed plus mbx squared plus m squared cx plus m cubed d is 0. Or, okay, if I divide everything by m cubed now, that's fine like that. But if I divide everything by m cubed, this is what I'll get. Ax cubed on m cubed, reason I'm just going to make the d on its own, all right? So I'm going to divide through by m cubed, and this is what I'll get. Ax on m cubed, I just want you to see the format, plus b, I'll have m on m cubed is 1 on m squared, so I'll have x on m squared. And then this one will be m squared on m cubed, which is 1 on m. So I'll have c times x on m. Notice I'm putting the x, because it's x cubed on m cubed, x squared on m squared, x to the power of 1 over m to the power of 1, plus d equals 0. The reason we're writing it like that is so that you can actually compare it with the original equation. Look at the original equation, ax cubed plus bx squared plus cx plus d. It just looks like the x was replaced with x on m. See how you're multiplying the roots by m? It looks like if you're multiplying, you go over m here. You're doing the opposite. Now, we're not going to use this method again. I'm going to show you the other method, all right? But just notice that if you're doing products of roots, it becomes, it's like the reciprocal of that, which is x on m cubed. You're replacing the x with x on m. Now, we're doing it the second method. It says this method that we've just used is useful for multiple roots of originals. It's also useful, I think, for plus, if the new roots are alpha plus 1, alpha minus 3, whatever. It's okay for those. But when you want to do, it's not good for squared and all that, is it? Oh, it is. Yeah. But it's not good for if you've got roots that are reciprocals, powers, or other combinations, whatever. Anyway, this other method I'm going to show you is much easier and faster. Okay? Do it, Claudia? Okay. So here's our same question. Write the cubic equation. So write cubic equation with roots m alpha, m beta, and m gamma. Okay, our first step is let the roots, let y equal mx. So let y equal mx where, I can't find it anyway. Let y equal mx, or our roots be, y equals mx, where x equals alpha, beta, and gamma. So should I write let the roots be? I think I will. Let roots be y equals mx, because the roots are m alpha, m beta, m gamma. So let the roots be y equals mx, where x is alpha, beta, gamma. Now you've got to put x as the subject. So therefore, x equals y on m. So you can already see that over m thing starting to happen. So we now substitute x equals y on m into your equation, into your polynomial. And so you'll get a bracket y on m cubed plus b y on m squared plus c y on m plus d equals 0. But now we don't, I know this is going to seem weird, but our next step is to just, it doesn't matter if that's a y or an x or anything else. So our next step is as simple as this. Replace the y with the x, or replacing y with x. We get a x on m cubed plus b x on m squared plus c x on m plus d equals 0. So that, okay, multiplying through by m cubed, wouldn't you get ax cubed plus, what would you get? Bx squared m? Or bmx squared, wouldn't you? Yeah, because that's m squared, you'd get bmx squared plus cm squared x plus dm cubed equals 0. And that's your required polynomial equation. Either one's fine. Therefore, required equation is that. And we're done. Okay, easy, isn't it? Just got to remember to do the method. So, okay, now next question. We've got that polynomial, that cubic 2x cubed minus 5x squared plus 4x plus 6. It has roots alpha, beta, gamma. Find the equation with roots alpha plus 1, beta plus 1, gamma plus 1. I mean, that other first method that we did on the page before will work, but it takes a long time. So we're just now going to stick with the second method. So we're going to go let the roots be y equals x plus 1. See where x is alpha, beta, and gamma. Do you remember what we do next? Remember to make the substitution into the polynomial. I don't want to substitute y, so I go, therefore, x is y minus 1. We now substitute that, so sub x equals y minus 1 into your polynomial. I'll just put it into p of x equals 0. And you get 2 bracket y minus 1 cubed minus 5 bracket y minus 1 squared plus 4 bracket y minus 1 plus 6 equals 0. And we can expand and do all that now before we replace the y with the x. So we get 2, don't we get y cubed plus 3y squared times negative 1, be careful. So it'll be minus 3y squared. Doesn't matter, plus 3y, negative 1 squared, plus, no, minus 1. We're using the minus 5 lots of, are we okay with that? Y cubed plus 3y squared times negative 1 plus 3y negative 1 squared minus 1 cubed, which is just 1, minus 5y squared minus 2y plus 1, all in brackets, plus 4y minus 1, minus 4 actually if you expand the bracket, and you'll get that equals 0, so therefore you get 2y cubed minus, are you getting minus 6y squared plus 6y minus 2 minus 5y squared plus 10y minus 5 plus 4y minus 4 is 0. Goodness me. Collecting like terms, 2y cubed, that's good, minus 11y squared plus 20y minus 11? No. Oh, I don't know if that's the answer. Plus 6 equals 0, plus 6 equals 0. So minus 5 equals 0. So we had minus 11 plus 6. I forgot the plus 6 to write it on from there. So now we just replacing the y with the x. Our required equation is 2x cubed minus 11x squared plus 20x minus 5 equals 0. Okay, that's the first part. I'm going to have to squish it up a bit. Now we have to find the equation with roots 1 on alpha, 1 on beta, 1 on gamma. So again, we're going to use exactly the same method. Let the roots be y equals 1 on x, where x equals alpha, beta, or gamma. And we're going to do exactly the same thing. We get that, therefore, x, making x the subject, x is 1 on y, and substituting into your polynomial equation, I've just got, and sub into p of x equals 0, we get 2 times 1 on y cubed minus 5 times 1 on y squared plus 4 times 1 on y plus 6 equals 0. Let's get rid of the y cubes on the denominator and let's multiply everything through. So let's just write that, multiply through by y cubed. We'll get 2 minus 5y plus 4y squared plus 6y cubed equals 0. And just replacing y with the x, our required equation is going to be 6x cubed plus 4x squared minus 5x plus 2 equals 0. required equation, in other words, your equation with roots 1 on alpha. The required equation with roots 1 on alpha, 1 on beta, and 1 on gamma is. And that required equation with roots alpha plus 1, beta plus 1, gamma plus 1, etc. Oh. What we've been doing before, because the others can be written as 1 on x, x plus 1, right? This one, we can't write it in that way. So what we've got to do is try and come up with a combination of something that we've had before or something. So alpha, beta, beta, gamma, and gamma alpha can be written as the following. Alpha, beta, gamma on gamma, beta, gamma, alpha on alpha, gamma, alpha, beta on beta. But, are you okay with that? Alright, so, I know it's new, something new. So alpha, beta, beta, gamma, gamma, alpha can be written as, see how I'm writing it as product of roots 3 at a time, product of roots, product of roots. Okay, instead of but, I can put and. We know that alpha times beta times gamma, looking up at the original equation, what's alpha times beta times gamma? Looking up on the first line underneath example 2, isn't it minus d on A, which happens to be negative 6 on 2, which is negative 3. So therefore, see how these are our roots? They can be written as that. Okay? Now, therefore, our question now becomes, therefore our required equation has roots. I don't want to have alphas and betas and betas and gammas and gammas and alphas. I just need alpha, beta, gamma. Isn't that minus 3 on alpha, minus 3 on gamma, minus 3 on alpha, minus 3 on beta? So it's just a change in our question. Because those 3 roots can be written as alpha, beta, gamma on gamma, beta, gamma, alpha on alpha, and gamma, alpha, beta on beta, and we know that the numerator of each of those happens to be negative 3, now the question does not become write the equation with those roots, it's write the equation with these roots, minus 3 on gamma, minus 3 on alpha, minus 3 on beta. Yeah. No. So now, what are we going to let y equal? Just minus 3 on x. Do you get it? It's much easier. So now, what we're going to do, let the roots be y equals minus 3 on x, where x equals alpha, beta, gamma. So therefore, x equals minus 3 on y, and subbing that into your polynomial of x equal to 0, we get, what do we get? 2 times minus 3 on y cubed minus 5 times minus 3 on y squared plus 4 times minus 3 on y plus 6 equals 0. Let's multiply through by y cubed. We get negative 54. I think I've done something wrong. Wait. Factor of everything there, but look, we can simplify at the very end. So we've got minus 27, minus 54, so multiplying through by y cubed, we get minus 54. That's 9 times minus 45 y minus 12y squared plus 6y cubed equals 0. Dividing through, why have I got, yeah, that's multiplying through by y cubed. Dividing through by 3. actually, yeah, we get minus 18 minus 15y minus 4y squared plus 2y cubed is 0, and replacing the y with an x, and let's just write the highest power first, we get our required equation with those roots is 2x cubed minus 4x squared minus 15x minus 18 is 0. Yes. Good. Equation x cubed plus 4x squared plus 2x minus 1 has roots alpha, beta, gamma. Same method again. Find the cubic equation with roots alpha squared, beta squared, gamma squared. It is the same method, but there is something a little bit different about it. So we go, let the roots be y equals x squared. So it is x squared. It's not going to be x. Y equals x squared, where x equals alpha, beta, gamma. Remember, you've got to make x the subject. It's the same method every time. X equals plus or minus root y. Now, you'll notice I noticed in one of the books they weren't putting the plus or minus, but you should really be putting it in. All right? So x equals plus or minus root y. We're going to substitute that into your polynomial of x equals 0. And that equation is supposed to have an equal 0, by the way. So in my question, I'm missing an equal 0. That's not an equation, that's an expression. Equations have equal 0. Substituting that into polynomial of x equals 0, I get plus or minus root y cubed plus 4 times plus or minus root y squared plus 2 times plus or minus root y minus 1 equals 0. Now, how are we going? What's root y cubed? Isn't it y root y? Yep. But it's going to be plus or minus y root y. Plus or minus, actually it won't be plus or minus, it's just plus, because when you square the negative, you'll always get a positive. So we get plus 4y. We've still got a plus or minus 2 root y minus 1 equals 0. The way that you're going to get rid of this plus or minus is that you're going to keep the plus and minuses on the left, and you're going to take everything else over to the right. So we're going to keep it as plus or minus y root y on the left, plus or minus 2 root y on the left is equal to 1 minus 4y on the right hand side. Now I can square both sides and I'll get rid of the plus or minus. Squaring both sides, I'll tell you why. If you just treat it as the positive, just pretend they're both plus, okay? You will get I can either keep both pluses in front or I can pull the minus out of the front. Do you get what I'm saying? I can either say, yep, they're both plus, and I'll get y root y plus 2 root y squared. Or if I say that they're both minus, you get minus y root y minus 2 root y squared, and pull the minus out, and you're going to square it, and the minus goes. Okay? I don't believe we've got to do the other combinations. Okay? So we've just got, it's just going to be, so squaring both sides, it's just going to be y root y plus 2 root y. I'm going to put the plus or minus out here. Do you see what I'm doing? Equals 1 minus 4y squared. So I've just put the plus or minus to the front. Because each of those terms have a plus or minus in front of them, let me put it to the front. When I square it, it's positive. So I've got y squared, y cubed, plus 4, 2 lots of that times that, 2y squared. Because it's 2 times that, because that gives me y times y, and 2 times 2 is 4. Plus 4y. That squared will give me 4y equals 1 minus 8y plus 16y squared. And now let's just take everything over to the left. Y cubed minus 12y squared, I think plus 12y minus 1 equals 0. Again, replacing the y. Where? Yes, it is. Yeah. Replacing the y with the x, we get x squared, x cubed minus 12x squared plus 12x minus 1 equals 0. That's your required equation, is that. That equation has roots alpha squared, beta squared, gamma squared. Okay, so same method, just this plus or minus thing. Keep the plus or minuses on the same side. Take anything else over to the other side. Bring the plus or minus out, and then do your squaring. Then you don't have to worry about the plus or minus. All right? Now, hence, part B, evaluate alpha cubed plus beta cubed plus gamma cubed. Okay, let's start. Now, we know that, let's start with our equation, x cubed plus 4x squared plus 2x minus 1 we know has roots alpha, comma, beta and gamma. If it has those roots, sorry, that's an equation. I should write x cubed plus 4x squared plus 2x minus 1 equals 0 has roots, I just want to finish this, has roots alpha, beta and gamma. Doesn't mean you can substitute in alpha by the factor theorem. If those are the roots, if you substitute alpha in, you get 0, beta in, you get 0, gamma in, you get 0. Therefore, we can say alpha cubed plus 4 alpha squared plus 2 alpha minus 1 equals 0, beta cubed plus 4 beta squared plus 2 beta minus 1 equals 0, and gamma cubed plus 4 gamma squared plus 2 gamma minus 1 equals 0. That's the only way we're going to get alpha cubed plus beta cubed plus gamma cubed. What we're going to do is I'll just go equations 1, 2, 3, adding these together. So adding these equations together, we get, let's use some brackets too. We get alpha cubed plus beta cubed plus gamma cubed plus 4 lots of alpha squared plus beta squared plus gamma squared plus 2 lots of alpha plus beta plus gamma minus 3 equals 0. Now, but nearly done. But alpha squared plus beta squared plus gamma squared are the roots of, aren't alpha squared, beta squared, gamma squared the roots of this equation that I just worked out? Are the roots of x cubed minus 12x squared plus 12x minus 1 equals 0. I just did it in part A. So therefore, alpha squared plus beta squared plus gamma squared, isn't that sum of roots 1 at a time? Therefore, it's minus b on A, which is minus negative 12 on 1. Minus negative 12 on 1, which is 12. I also know that alpha plus beta plus gamma is from the first equation. And alpha plus beta plus gamma, because they're the roots of the first equation, alpha plus beta plus gamma is minus, no, it's fine. Gamma are the roots of x cubed plus 4x squared plus 2x minus 1 equals 0. Therefore, alpha plus beta plus gamma is minus b on A, which is negative 4 on 1, which is negative 4. So therefore, you know how you're trying to add up this big thing at the top? Therefore, alpha cubed plus beta cubed plus gamma cubed, I'm just going to go that becomes that plus 4 times what? 12 plus 2 times negative 4 minus 3 equals 0. Therefore, alpha cubed plus beta cubed plus gamma cubed is, well, that's 48, 40, negative 37 as required.